Our last problem, problem 7 for the test 1 review for the physics bootcamp. A rock is thrown from the roof of a building with an initial velocity of 10 meters per second at an angle of 30 degrees above the horizontal. If the height of the building is 100 meters, how many seconds will it take the rock to hit the ground? And what is its range? Okay, so we want to know how many seconds will it take for the block to hit the ground, for the rock to hit the ground. So we're throwing the rock from the height of a building. The height of the building is 100 meters. So now we're throwing it at 10 meters per second. But this time, instead of the previous problem, the bullet was going horizontal. This time it's launched at a 30-degree angle. The projectile will go like this. It will hit the ground. We want to know the total time. We want to know the range. Usually when we say range, we mean the horizontal distance that the rock is going to go. By the time it hits the ground, what's this horizontal distance? So usually the first thing you want to do in projectile motion problem is you take your velocity, break it into its x component, into y component. We know that the x component never changes, right? So v initial x equals v initial cosine of theta 10 cosine of 30, right? Cosine 30, this one, that will give you v initial x. V initial y is going to be the vertical component, right? So always break it down into the two components. 10 cosine 30, that gives you 8.66. because cosine 30 is rad 3 over 2, right? And then v initial y is equal to v initial sine 30. And then that's going to be 10 sine 30. So sine of 30 is going to be 1/2, so that's going to be 5. Okay? So now, which direction should we go now? Should we first analyze the x direction? Or should we first analyze what's happening in the y direction? This is kind of where the beginning physics student sometimes might go wrong. They might start out with the x or they might start out with the y. Maybe they don't know which direction to take. Well, here is your clue. Which piece of information is given to you? Well, a piece of information is given here, 100 meter, and that's in the vertical direction. You have no knowledge of how far it's going to go here, but at least you do know the vertical direction is 100, right? So once you break it into the components, you want to first analyze what's happening in the y direction, not the x, because no knowledge is given to you, no information, right? So let's go to the y direction now, and it's given to you that the height of the building is 100 meter, right? So we say y final is equal to y initial plus v initial yt. What units are we in again? Meters, meters. So half of 9.8, negative 4.9, right? Because it's negative 9.8. Negative 4.9 t squared. Okay, what's my y initial, what's my y final? Well, you could put your xy coordinate either up here or down here, but it doesn't matter really. So if you put it down here, what's my y initial? Well, my y initial is 100, right? What's my y final then? Well, once the rock lands down here, the y final is 0, right? It's down here. So this one will be 0. What's my v initial y? Well, that one is what I have here, 5 minus 4.9 t squared. Or I could have put my xy coordinate up here. Then what would my y initial be? Well, my y initial would be 0. What would my y final be? Well, since it ends up below where I threw it, my y final is negative 100. Well, the solution to this equation is the same as the solution to this equation. Why? Well, if you take the 100 over there, you get a negative 100, right? So as long as you are consistent in where you put the axis and you're consistent with your signs, then you should get the right answer. Then what are you going to do? Well, you're now going to say, well, you're basically going to take this and make it into a quadratic equation, right? Take this to the other side, 4.9t squared. Bring this to the other side, becomes negative 5t. And then this one stays on the left side, negative 100 equals 0. So you could either use the TI quadratic equation solver, or you could use the quadratic formula. T is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Right? The quadratic formula. So now we're going to have negative, my b is negative 5. And then you have b is equal to b squared. So since negative 5 squared, so that's going to be 25. Minus 4. What's my a? 4.9. What's my c? Negative 100. Divided by 2 times what? A, which is 4.9. So what's the answer to that? Okay. Well, you're going to have here the 2 negatives cancel. And you have 25 plus 400 times 4.9. So let's just do it on the calculator. 25 plus 400 times 4.9 gives you 1985. So simplified, it's going to be the negative and the negative becomes 5. 5 plus or minus square root of 1985. Sounds like a date, right? Divided by 2 times 4.9, which is 9.8. Well, one of these is going to give me negative answer. I don't want negative answer. If I do 5 minus square root of 1985, it's going to give me a negative time. So I'm just going to keep the positive, right? So square root 1985, and then add it to 5, divided by 9.8. The answer comes out to be 5.056 seconds. So it takes 5.056 seconds for the rock to hit the ground. Now we analyze that. What's the horizontal distance that the rock goes during that time? Now I can analyze what's happening in the x direction. We know x is equal to v initial xt. Gravity does not act along the x direction, right? So v initial x, we calculated it earlier, 8.66 times the time we already have, 5.056. Okay? And then what's the answer for that? Well, you just take 5.056, multiply it by 8.66, and you get 43.785 meters. Okay? So we got 5.06. Depending on how you get, see, 5.06 times 8.66, 43.8. Yeah, see, if you did, depending on how you round it, I have done it earlier here, the problem, and I have a 5.06 here. It just depends on how you round this. If you round this as 5.06 and you multiply it here, you might get an answer like 43.82 meters. Right? If you keep it as 5.056 and multiply it, you get 43.78. I always tell my students in the test, try to keep 2 or 3 decimal places, and then when you're multiplying it, and then at the end, you can then round your final answer. But even if you kept 5.056 or 5.06, the final answer is still going to be close. Okay? On my test, if someone has this or has that, well, 0.82, 0.78, they are relatively close, so I do not deduct points for that, as well as other teachers too. They will count both the same value because it's just a matter of rounding error, okay? So either answer is fine. So that's the way to calculate the range that the rock went.